The Denver Convergence Vorticity Zone, or DCVZ, in northeast Colorado is another notable one. The DCVZ occurs when low-level southeasterly winds flow up and over the Palmer Divide, an east-west protrusion of higher terrain just south of Denver. Due to friction, these winds bend toward the northwest and can collide with northwesterly winds flowing down the slopes of the Rockies, creating a convergence zone that's typically situated just east or southeast of Denver. In this example, note the stationary fine line in reflectivity that was draped through the eastern portions of the metro, evidence of a DCVZ boundary in place. When analyzing these terrain-induced convergence zones, you can also use the velocity product to identify areas of vorticity or spin along the boundary, which can be stretched into the vertical to aid in non-supercell landspout tornadogenesis underneath nascent updrafts.
Safety is king. That's why these rules are not optional. Free ebook link in description.
Fronts and dry lines can also be identified using radar, and the reflectivity fine lines associated with these features can often be quite sharp, like this dry line in southwest Kansas. As you may know, the dry line is a boundary between hot, dry air to the west and warm, moist air to the east that can initiate storms in many severe weather environments. Prior knowledge of the environment is necessary to correctly identify which type of boundary the radar is depicting. In addition to identifying boundaries, radar can also help you see areas of circulation. These circulations can be convection-induced or terrain-induced. One of the best examples of the latter is the Denver cyclone. The Denver cyclone is not the same thing as the DCVZ, which we mentioned earlier, but both have to do with the terrain features present in northeast Colorado. The Denver cyclone is a cyclonic or counterclockwise circulation that develops within the lower elevations in and around the Denver metro area as low-level southeasterly flow goes up and over the Palmer Divide. The flow is both bent by friction toward the northwest as it goes over the Palmer Divide and blocked by the massive obstruction that is the Rocky Mountains, so it curves back to the south and creates a cyclonic circulation. A DCVZ boundary often does develop when the Denver cyclone is in place, but it can occur without the assistance from the cyclone as well. Here's an example of the Denver cyclone in action. Notice the broad counterclockwise flow in the weak reflectivity echoes near Denver. These kinds of circulations can produce enhanced lift that promotes thunderstorm development and provide additional low-level vorticity or spin along with the enhanced low-level wind shear, especially where winds are most backed, that can favor tornadic activity of both the non-supercell and supercell variety.
Remember to check out those links in the description below, and then watch another video.